Okay, today we're going to talk about conditional probability. It's day 154 in our class. And conditional probability means condition, okay? Let's just say like your parents are like, I'll let you go to prom on one condition. Okay?
What is it?
Whatever it is. Let's just say I'll give you, the condition is that you clean your room, okay? Okay? And let's just say they're very firm. They'll like lock you in chains if they don't let you go and tell you when to clean your room, okay? Okay, will you go to prom if your room is dirty? No. No, they're going to chain you up, remember?
I'll break down.
Okay, anyway, so let's keep going here. So that's condition, okay? Conditional probability. So another example, we can figure out probabilities based upon events. For example, let's say tomorrow, I'm going to ask you this question, or right now. What's the probability that school is closed tomorrow because of a snow day?
0.
0. Why? But don't schools close when there's too much snow outside? Okay, what condition has to be met before they even close the school? That's actually snow. What's the probability of it snowing tomorrow? 0. Okay, good. Excellent. Okay, so snow day. Or another, conditional probability is, okay, ready? Let's say I pull out let's just do this. Let's say I pull out a red card. Okay, what's the probability of me pulling out a red card? 50, right? 26 out of 52, right? Okay, I take it out. It is pulled out. Okay, I'm not replacing it. What's the probability of me pulling out another red card given or on the condition that I've already pulled out one red card?
49.
No, tell me the fraction.
26 over 52 times 25 out of 52.
How many cards did I
Let's start again. Taking it. That's good. We're all thinking. Okay. How many total cards in my deck right now? I just put it. We're starting over. How many?
52.
How many red cards?
26.
Okay, good. Okay. Starting again. I'm gonna take out a red card. How many total cards are there in here?
51.
How many red cards?
25.
Okay, good. Okay. Let's start again. What's the probability of me pulling out a red card given that I've already pulled out a red card and not returned it to the...
25 out of 52.
Good. 25 out of 51. Does that make sense? That's the condition, given the condition that I've already taken out this card. Okay? Does that make sense? So we're talking about conditions, okay? Conditional probability. All right? So these are the steps, and you want to pause the video and write this down. This is actually step 3 here, not step 1 again. I don't know why the computer does that sometimes. Okay? Okay, but you could think of conditional probability like this, okay? For example, what's the probability of me or of school closing tomorrow if there's a snow day tomorrow, or if it snows a lot tomorrow, okay? Right? Well, we need to wait for it to snow, right? Is it going to snow at all? No, so we can't really calculate this piece because the second circle will not exist for tomorrow, okay? So it's where the two overlap, okay? So, for example, what's the probability of a student being a female and having a B in my class right now?
0.
No, there's girls with B's in here.
Raise your hand.
Okay.
Who's a girl? B is good.
Who's a B that has a girl?
Wait, what?
No. I'm just playing. I know, I'm just playing. Okay, so think about that. That's what we're going to get to. I'll show you that later. Here we go. We'll talk it. We're not good. That's private, okay?
I really don't think it does. I have a D. Ashley has a D.
I have a
She
D.
said she has a C.
I have a D minus right now.
She's a C.
But if
All right, we're going to talk about conditional probability. So this, I'm going to show you how to use a formula that's on step 2 of your notes. So and we can figure out the probabilities of things based upon the information that's given. So a math teacher gave her class 2 tests, okay? 25% of the class passed both tests. That's the information we know. That's the probability. There was a 25% chance that you passed both tests, okay? But there's also, we know that 42% of the class passed the first test, okay? So what percent of those who passed the first test also passed the second test? So we want to know how many people passed the second test given on the condition you passed the first test. Does that make sense so far? Okay, so we need to know if you passed the first test or not. And we need to know what information we have here. So the first thing when we're trying to find conditional probabilities, we're going to use this formula, which is going to be the probability of event B given that event A occurs. So the way we read this, probability, open parentheses, event B, and this vertical line means given or that the condition of A occurring is equal to the probability of both event A happening and event B happening together all over the probability of event A, okay? So the information on this one, on this example, we have tests, right? We have a first test and a second test. So we want to know what's the probability of someone passing the second test given that the first test is passed, okay? So we need to put in the probability of both the first and second test. What's the probability that they pass both? All over the probability that they pass the first test. So we know this information from this example. Okay, so the math teacher, first and second test, what's the probability they pass both on this example? 25%. So we put that down as the numerator, 0.25. Okay, the probability that they pass the first test in this example is 42%, or 0.42. Then we use a calculator. Okay, let's all pull out your calculators. This is, I know how to do this on my calculator, so I want you to practice. Everyone's doing this. Pull it out on your iPads or wherever. Okay, calculator. So what is 25 hundredths divided by 42 hundredths? Okay, good. So then we're going to round, and the answer we're going to move over 2 decimal places, which is 59.5%. So that means that the probability of you passing the second test, given that you've already passed the first test, is going to be 59.5%. Okay? That's number 1.
So we just divide by the probability. If one happens.
You have to know which probabilities to divide. Okay? So the big idea here is that you have to set up the equation. You have to figure out what are we trying to figure out. On this example, we're figuring out what's the probability of you passing the second test, given you already passed the first test. And we should know what the probability of passing both tests are and the first test. Okay? You good? Okay, so number 2, here's the next one. The probability that it's Friday and that a student is absent is about, or is 3 hundredths, meaning 3%. Meaning if it's a Friday, let's say that Mr. Kelly's like, hey, it's Friday, I noticed that 3% of students are absent on Friday. Okay? That's the probability. All right? So since there's 5 school days in a week, the probability that it's Friday is 0.2, right? So how many days in a week, everyone? No, it's school days, I mean. How many school days in a week?
5.
How many school days are Friday?
1.
So what's the probability that's Friday?
1.
1/5, which is 0.2. Good. So what's the probability that a student is absent given that today is Friday? So let's pretend today is Friday, okay? So the first thing we want to do is set up our question. What are we trying to figure out? I want to figure out what's the probability that someone is absent given that today is Friday, okay? That's what this problem is asking me. Okay, so then I would apply the formula that's on step 2. So we want to know what's the probability of both it being someone being absent and Friday, and then we want to know what's the probability that today is Friday. So then we start inputting our numbers in. The problem says that, hey, you have a 3% chance that you're going to be absent and it's Friday. And today is Friday, so there's a 0.2% chance that it's Friday, okay? So we divide, and when you do that, your answer is going to be 15%. So the probability that someone is going to be absent, given that today is Friday, is going to be 15%. Does that make sense? Okay. Now, a lot of this is analytical and conceptual. It's hard. This is a hard thing to do, but when you are able to understand it, you're able to make decisions and, you know, get some assumptions going. Yes? What's up?
On the last problem, number 1, when you divide, like on a calculator, you got 0.5952 or whatever. Do you just put the decimal point behind the 9, like, for everyone?
You move it 2 places to the right,
Okay.
so we change it to a percent. Yep. Okay? Very good. So what we're going to have you do is, today is Thursday, let's have all the 4s talk. 4, 4, 4, 4, 4. There's no 4 here, so Thomas, you're the talker today. 4 and 4. Pick a problem. I don't need you to do both. Pick one problem that's easier for you to explain. And I want you to explain how did I set up the problem, answer it, and also what does the final answer mean? Okay? All my 4s. Let's go. Ready, set, and go. Okay, so the next one. Here we go. Let's do a few more. So we're gonna do number 3 for the sake of time. I'm gonna skip because I want to show you a couple other examples. Okay, a jar contains black and white marbles. Okay, can you all imagine a jar with black and white marbles? Okay, 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble is 0.34. So we don't know how many marbles there are in here. There could be like hundreds in here, but we know that the probability of selecting a black marble and then a white marble is going to be 0.34. Does that make sense? And when we select each one, we're not replacing them back in. Okay, and the probability of selecting a black marble on the first draw is 0.47, which means if you were just to like start over and you just pulled one out, there's a 47% probability that you would pull out a black marble. Okay? What is the probability of selecting a white marble on the second draw, given that the first marble drawn is black? Okay? So let's pretend that this deck of cards are the marbles. Let's say the first draw was black. That's not black. Okay? What's the probability that the first one is white? Or I'm sorry, the second one is white. Okay? So here we go. Let's write this down. Not the problem, but the work. Okay? So let's figure out what we're trying to answer. What's it asking for? What is the probability of what?
Selecting
White marble.
Okay, so we're going to start with a white marble, okay? So, probability of white, given what? That we've done what already? Good, so we're putting that down. Okay, in the numerator, it's equal to what? What probability should we have at the numerator? Probability of what? White marbles and black marbles. The probability of selecting both white and black in the first 2 draws. Okay. What about in the denominator? What information do we know? The probability of selecting what? Good, because the first. Well, actually, it's the probability of selecting black, right? Because the first marble we drew was black, right? Okay, so let's have you put the numbers in and calculate it. I'll come back to you in about 30 seconds. What's the answer, everyone? Good, 72.3%. You should have set up your problem like so. And you should get this decimal, move it over to the 2 places to the right. So the probability of you selecting a white marble after selecting a black one is going to be 72.3%. Okay? Okay, and if you're on the video, you can pause it and read this and try it on your own. And pause it.
Nice.
Okay, here's your answer on the video on number 4. Okay, I'm going to move on, though, because I want to show you something else. Okay, so I want you to know that some of the problems are not all like, you don't have to be so complicated when you do it, okay? So, ready? I'm going to take out a red card, okay? What's the probability of me taking out a red card the first time? Good, 26 out of 52, okay? Ready? What's the probability? Here's the question. What's the probability of me taking out another red card given that I already took out a red card?
25 out of 51.
Why did you do that so quickly? You did it earlier, but also
You just subtract the number.
you just subtract a number, right? We just did conditional probability without doing that big formula, okay? On some problems, that's how it is. On other problems, you might have to draw a diagram. For example, on this one, okay? So a student in a snowy area made the following observations. Okay, so let's say you you knew a friend that lived in like Colorado or like where it snows a lot. Okay, so on all snowfalls, the student realized 5% of snowfalls are heavy, meaning they're really like super bad. Okay, after a heavy snowfall, schools are closed 67% of the time. Okay, so it's like heavy snow. The kid realized, hey, 67 or 2/3 of the time, the school's closed. But after light snowfall, the student also figures out school's only closed like 3% of the time. Very rarely does it ever close. Okay, so I'm not really asking a question like when the schools close. I want you to see like how the probabilities work out. So imagine if you're the kid, okay? If it snows, what kind of snow can you get? What are the two types of snow you can get?
Heavy snow and light snow.
Good, heavy and light, right? And what's the probability of heavy snow?
5%.
5%, which is 0.05, right? So if it's a 5% chance of heavy snow, what's the percent chance of light snow? 95%. Good. Y'all see that? Good. So let's just pretend there was a heavy snow. What could happen at school? What are the two things that could happen? It could close or stay open, right? After a heavy snow, what's the probability of it staying closed?
67%.
Good. And what's the probability of it staying open then after a heavy snow? Y'all see that? Okay, good. Now let's just go back to, let's say it was a light snow. What could happen at school after a light snow? It could close or stay open, right? You see that? The probability of it closing is 3%, so the probability of it staying open is 97%. Y'all see that? So there's multiple paths that can happen to your life, and there's probabilities. So what's the probability of it being a heavy snow and that the school closes? Okay? So what's the probability of that happening when it's snowing? Well, you could just multiply it. What's 0.05 times 0.67? You go to your calculator and you'll get 3.35%. Okay? Does that make sense?
Yeah.
So can you calculate these other ones for me? What's the probability of the school staying open after a heavy snow? Can you all get your calculators out and multiply these? And what's the probability of these other ones? School closed after a light snow or school open after
1.60.
light snow? Oh, what was that? Staying open?
1.65.
1.65? That's right. Next one. What's the probability of school closing after a light snow? You're just
305. Right, 3.05.
2.85%.
Okay, good. What's the probability of a school staying open if it's light snow?
94.
You're just multiplying. You're multiplying. What is it?
92.1.
Okay, 92.15%, right? Does that make sense? So let's say you're a student and you're like in a snowy area, you'd be like, well, if it snows, should you think you're probably going to go to school the next day?
Yeah.
What is the highest likelihood if it's snowing? What's the highest probability?
Light snowing lightly.
You're probably going to go to school, right?
Yeah.
What's the probability? Let's add these two opens. What's 92.15 plus 1.65?
93.7080.
93.8, right? That's a very high likelihood you're going to go to school, even if it snows. Does that make sense? Is there a possibility you're not going to go to school?
No.
Yeah.
Oh, yes.
Yeah, of course. You could have a light snow and not go to school, and you might have a heavy snow that might not go to school. Okay? Yeah.
For like the 92.15, can you put like 92.2
You could do that, yeah. It depends how detailed or precise you want to be. Okay? I like going 2 decimal places myself. Sometimes you need 3, depending on the problem. Okay, we're almost done here. Okay? Last example. Remember how I said conditional probability? You could look at it simply. You could look at it as a chart. You could look at it with that formula I taught you. Here's another example. Ready? Let's go throwback Thursday to junior high. Okay? Let's say there's a classroom that you were in, and there were boys and girls. Okay? And there were kids that wore deodorant, and then there were kids that didn't wear deodorant. Okay? Right? Throwback Thursday, right? Let's pretend that there were 17 girls that wore deodorant and 2 girls that didn't wear deodorant. Okay? That happened. We know that, right? And let's pretend that there were... You kids, your faces are great. Let's say there were 12 boys that didn't wear deodorant. That's pretty true, right? And then there were three boys that did wear deodorant. Okay? Yeah, because they're like 6th grade, okay? They don't know yet that they smell, okay? Okay, that happens. So, back when Axe was cool in junior high, you just like, in class, okay, let's think about conditional probability. How many total kids are in my class?
We have about
In this class?
34?
34, good. How many kids?
34.
Okay, last question, we're all done. What is the probability... Hey, I'm almost done. Give me that last 2 minutes. What is the probability that someone is wearing deodorant given on the condition that that person is a boy?
15 over 19.
Okay, listen to the question.
Oh,
What's
okay,
the
sorry.
probability that the person is wearing deodorant given that the person is a boy?
12 over 21. 22. 12 over 22.
No, let's think about that. How many boys? We want to talk about given. How many boys are there?
15%.
15, good. How many boys? So we're only talking about the boys. Do I even care about the girls for this question? No. So we're now limiting our condition to all the boys. How many boys again? 15. So we want, here's the question. What's the probability that someone's wearing deodorant given that there are
3 over
boys?
12.
No, how many total boys are there? Good, so which is 1/5, which is 20%. Does that make sense?
Yeah.
So did we do this large equation here? No. So you need to like kind of think about it as like sensibly as you can, and that's it. All right. That concludes the lesson. Thank you.